Hello again, this is UML Operator. Hello and welcome back. If you're new to UML or you're advancing in component diagrams, you're in the right place. So what we're going to be doing is walking through how to create your first UML component diagram using Sparx Enterprise Architect. By the end of the video, you will have a solid understanding of how to use component diagrams and to model software architecture effectively. So as we've done in previous videos, you're going to or should start in the builder page that Sparx provides. You type in component, you get down to component diagrams. And the ones I recommend is starting with the starter component diagram. And then the next exciting one to me is the one at the bottom here, and that's component interfaces with JSON payload. So you can look through all of these and then create some play models in your learning environment to go through each one of these. But I'm not going to do that in this session. We're going to jump right into creating our own component diagram. So we're here in Sparx in my common layout, right? A toolbox on the left, I have browser in the upper right, and I have notes in the lower right. And I have various tools that I'm use. You've seen me do that in previous videos, and let's get started. So we've created a folder here called My First Component Diagram, and we're going to create a diagram. So new diagram, and then when we get here, we're in UML structural. We're going to choose component diagram. We're going to accept the parent package name here, and we'll go ahead and hit create. So we've created a component diagram with all the component tooling to get started. Now I've renamed the diagram called personal computer into its own namespace, personal computer, because that's what our subject is. And I added my own logo and tagging for this demonstration. All right. Now over in our tooling, our first element here is called packaging component. And I'm going to use this one for this demonstration. And we're just going to give it the same name of the package, personal computer, because that's what the component is that we're talking about, right? And you'll see over on the right, it will create an element over in your browser, brings up the builder page, and we're going to use component. Don't worry about these other ones. Let's just use this top one right here, and we're going to create. So essentially what we've done is we've created another diagram separate from this model. I want to bring in my logo and name into this one. So Control C to copy, and then Shift Insert to bring it in. And it's just a copy of the logo and element. All right. So now we're inside a package component in the namespace, as we see over on the right, and let's get started. Now I'm in Sparx version 17, build 1704, and I'm going to be utilizing timelines. So if we go to design and we select timelines, it brings up this window. For me, it's in the upper right. And we can see today at this particular time, we started with nothing, right? And then what we did was we added in our logo and name. So that's where we are right now. Each time you save when you're in session, it puts it there. All right. Then what we can do in timelines, which is pretty cool, is we can save to snapshots and then starting, learning, or whatever you want to put in here. And now we have it. Thank you very much. We have it over in snapshots. So now I can create an image snapshot at any time. I can show the snapshot. All right. And the reason I'm showing this feature is because when you're doing your own learning, you're going to be learning in stages, either over minutes, hours, days, or weeks. And you're able to come in and look at where you left off. And if you're not in version 17, don't worry about it. Let's just go ahead and baseline. We're going to baseline just this package. We're going to hit Control, Alt, and B and bring up baseline. We're going to create a new baseline and we're going to version it 01. We can leave the date and time in there or put anything that you want into that. All right. Now, since we're doing a component diagram for personal computer, let's bring in some components. The first one is going to be motherboard. Every computer has one of those, right? Now, once you bring in an element, a little tip here, if you hold down Control and left click on your mouse, it remembers the last element you brought in and we can get started. So we have a central processing unit. We're going to just Control click in here and dump them in. We have some random access memory. We need storage in our computer, right? And we need a power supply. Can't get away without that. And what else do we need? Oh, of course, we need some I/O. I was going to use little I, but let's just I/O devices, keyboard, mouse, etc. So we have some of those, all right? So let's just bring in some components that we're going to start to play with, and let's move into adding some ports. So components are building blocks for your software architecture, and a component diagram is used to visualize and organize your high-level architecture of that software system that we're going to be diving into. I'm going to move around some things here, and let's just make this one a little wider to bring in our ports. So we're going to bring in a port, just drag and drop it in the general location that you want it. If you were to take a port and drag it down near the bottom, it'll show up at the bottom. If you do it at the top, left, all right? And then you can always move them, right? So a port is essentially interfaces or interaction points that define how components are going to communicate with each other. And we'll see that in just a moment. Now, our first port, we're just going to double click on this and open up. You get the Sparx dialog box in here. And the first port is going to be the CPU slot, all right? And we're just going to go ahead and just put that and keep it simple. And we can move this around. I like having it on the inside. Doesn't matter. You can move it to the right. You can put it below by default. But I'm going to have it, I like having it inside the component because we're going to be drawing some connectors between this and other components. Now, to keep the video short, I went ahead and added the other ports in here. We're just going to do 5 at this particular point. We're going to dump them in, and then what you can do is just select them and then go to layout, and you can space these evenly apart. All right, so you're able to build component diagrams very fast in Sparx, and there's some other tips we'll try to show later, but let's just go through it. Then once we get a size that we want, here we go. We can move this anywhere we want in our diagram as we get going. The next thing is make sure that you're putting a minimal amount of notes under each port so that you understand. If we bring notes over here, you can see that each one of these, we basically added a description of each port as we're building them out. This is especially going to help you when you're collaborating with others and when you're coming back yourself and going over your architecture design. All right, let's add some ports to these other components. I'm going to move these over to the right. We're going to focus on CPU next. I usually like to make it a little long because we're going to be adding 3 or 4 ports to our CPU. So we're going to come over here and grab port, and we're going to put it over here on the left. And then we're going to grab another one, put it over on the left, grab another one, put it over on the left. And let's see here. I think I am going to do just 4. There's certainly more ports that you may be modeling in as you're going forward. And then again, I like to have the descriptions inside the component. It's totally up to you whether you want to leave them at the bottom or put them anywhere else. All right. So we're going to go through and name each one of these ports next. All right, started naming these. So we're going to bring this one over here. This is going to be, we're just going to double click in here. And this is our power port for our power supply. Again, put in a description in here to help you understand the nouns and verbs that you're dealing with. And there we go. All right, so we've got these in here. Let's go ahead and organize them a little bit. We're going to space them apart, equally apart. And then I'm just going to shorten it up for space purposes. So there's our CPU. Again, make sure that you're describing your ports as you're modeling them. So when you come back, you're trying to go really fast. I'm going to drop in 4 ports and I'm going to give them names and then I'm going to move on. Well, just drop at least a short description in here. In some cases, you may get extremely verbose, however you want to define your particular ports, like for instance, when you get into control, it might not be as simple as just putting in, oh, I got a control bus port. Well, there's a lot of things that go through that on the CPU, all right? And you might want to define and give examples to your team and your collaboration as you're going forward. All right, I've added in the rest of the ports to these components. Let's talk about, we described what a port is as an interface. Let's go up, because I said I was going to do it, and use the interface element, all right? So we're going to drag and drop one in here, and let's just call this one, there's many that are here, data access, so we'll use that, right? So data access would be between something, for example, in your data bus over into your RAM. So let's move these around here, and let's bring up RAM, set it right up here. So your data bus to your data bus, you have a data access interface, right? So when do you use an interface? So this is basically when you want to define and name an interface explicitly, right? Separate from the components. Now this becomes a portable element that I can use in class diagrams and other development needs as we progress. You can't do that with ports. In a moment, we're going to get into balls and sockets, assembly for connectivity, and the difference between the ball and socket or assembly is dealing with implicit, where you define only through connections. So the interface is where you're defining explicit. So you're sharing interface and detailed definitions separately from your component diagram and reusing it in here, all right? So let's get into connectivity and ball and socket exposed interfaces next. And hopefully that'll make more sense here in just a moment. Let me get this one out of the way. And the first thing we're going to deal with is the port data bus. I'm going to move it over to the right. I'm going to move this inside, and we're going to show a connectivity between this port and this port, all right? There's a couple of ways to do it. Now, the compliant way to do this is to use expose interface. So we're going to select this, and we're going to drag and drop it right onto data bus, and we're going to let go. And we get this dialog box that either is provided or it's required. Let's start with provided. I'm not going to put in a name yet. I'll show you how to fix that in just a second. And you can see it is a ball. So I'm going to drag this one. I'm going to do it again. I'm not going to drag it. I keep saying drag and drop. It turns into something that I can use. I am going to select where I want it, and it is bringing up this dialog box. This one's required. And this is known as ball and socket. So this one is required, and this other one, let me cancel. This other one is by default provided, right? So the provided interface represents a service or functionality that a component offers to other components. So basically it defines what the component can do or what the operation is that it exposes. On the other hand, a required interface represents a service or functionality that the component needs from another component, and it defines what the component expects to be available for it to function properly. Let's go ahead and name these interfaces. We can double click, and now we can change the name here, and we're going to use our convention here. Normally you wouldn't have a space. You would use the naming convention. Like the interface wouldn't have a space, it'd have an underscore, or using camel or what other convention that you're using. But we're going to keep this simple, and we're going to put a space so that it's human readable. And this one is called data access. So they're both called data access. This one's provided and this data access is needed. So how do you connect these? So this is the required interface over on random access memory, and this is provided by the central processing unit. We're going to grab this arrow, drag it over here, let go, and we have these choices. Now, delegate is more complicated subject. The simplest way is to use a dependency, and their usage is a dependency stereotype. Trace is a dependency stereotype. Just keep it simple and use dependency. And so if you have traceability, and for me, it's in the lower right here, and we select the socket here, we can see that this data access interface owned by, and then we can go down here, owned by RAM, depends on this provided interface by the CPU. And again, you can extend it, owned by, and you're able to see that CPU is what it's dependent on. So this is the correct story. If you were to reverse these by going into advanced, and I'll let you do that on your own while you're playing around. So reverse direction, this is not correct. The CPU doesn't depend on the RAM, it's vice versa. So let's change that back. That's how you connect your interfaces using ball and socket, or required versus provided. Required versus provided. And I wanted to spend some time going over that because that is often a mistake that modelers make when they're doing component diagrams, including myself. So traceability, turn it on. It's very powerful. If you don't know how to do that, I have videos on that, but essentially from the start, you go to diagrams, right here, trace, and again, mine's over in the lower right. Now, I do want to talk about assembly here because we put in ports, which I think is important. We use the expose interface ball and socket, which I think is the best way to do that. But the other way to do that is using assembly. So if you go over here, you can see in component relationships, assembly. Let's see if we can do this. So we're going to go over to RAM, which is requiring, we're going to drag this over, and it gives us in quick access a UML compliant assembly, right? And in this particular case, we see that the assembly puts the ball over on the CPU side, and it puts the socket over on the RAM side, which is what we want to do. So using assembly is another way to do it, but I like defining the ports and then just using these separately. When you double click them, you can't define them. You know, you'll define them through the association, the connector, but in assembly, it kind of does everything for you. It puts in the ball and socket, exposes as an interface, gives you the power of Sparx to define what is this relationship or connector. If I go to RAM and I look at everything that's associated here, assembly 2 is now the way the dependency is depicted, which is a correct representation. Let's start to wrap up. I'm not going to be able to do all of these. I'm going to move power and talk about that for a moment here. So we've got power here. We've got power here. Let's move storage out of the way. Let's bring our power supply in. All right. And what I want to do is move power output over on this side, put this inside like this, and let's bring in some required. So we're going to drag and drop that in there. This is required. And we're going to do another one over here for this power. It requires power, right? RAM's not providing power, neither is the CPU, so to speak, but the power supply is providing power. So let's bring one over here, provided, right? Take the default provided, and there we go. And so we can come in here and name each one of these power, but we'll do that a little bit later on, right? So right now, what we're doing is RAM is dependent on being powered up by the power supply. So what we're going to do is select the required interface, drag it over to the lollipop, the provided interface, and we're just going to use dependency, right? And we're going to do the same thing here with CPU. It requires power. Otherwise, not much is going to happen, right? And then now what we're showing here is that these and everything else that has power in it is going to do the same thing. And to do your plumbing, we're just simply going to right click on the element, and then we're going to go down into line style, and we're going to choose orthogonal square. So it does something like this. We can do something like that. We come in and name this power. Matter of fact, let me do that right now. Port, power, and this is power, all right? We're just going to call these interfaces, power. And then we can right click on this and then apply line style to everything of the same connector type, right? So now we've got one here, we've got one there. We can either keep them together, move them down slightly. I would keep them together for your plumbing, because as you got all this power that's coming in from these other components, you know, your plumbing is going to get a little messy. Your lines are going to get a little messy. Keep them together, right? All right, we're going to wrap up. There's certainly a lot more we can do. We can complete the connectivity between all these other ports that are here. But what we've talked about in this session is creating a component, naming the component, describing the component. We talked about interface right here using this element. And again, we could do an element for each one of these to be extended into our software design and implementation relevant to class elements that we're doing. In other words, outside. And we talked about ports. So mostly you're going to be using the component, you're going to be using the port, and you're going to be using the exposed interface elements. And then for connectivity, you're going to use dependency and or you're going to use assembly. And I'm going to go ahead and take this one out of here because I don't want it in here because I've already defined it. I don't need to do it twice, and so on. So there's so much more to talk about when I get into more advanced subject around component diagrams and interfaces and software design. We'll dive down a little deeper. All right. All right. Thank you very much for watching. We covered a great deal here. We started with a blank component diagram. We started building out our header. We added components. We started adding ports as we were going through. We defined the ports. We started adding interfaces. We started connecting those interfaces. We talked about various ways and wrong ways to connect interfaces. And then we wrapped up by connecting our power sources that we're going through. So I hope this video was helpful for you. Component diagrams are extremely powerful. We spent a long time talking about almost 25 minutes, maybe more. And it's very important we understand if you're going to be doing component diagrams to do them the best of your ability. Do you do component diagrams? Do you agree with what we've talked about today? I know that when I get with various modelers, there's approaches that they prefer. They agree or disagree. But when it comes down to data relevance, it's how are you telling your story and then being able to test and validate that you actually told the right story. All right. So until that next episode, thanks very much for watching and happy modeling.